So let's zoom in for a closer look at the James Webb Telescope. The $10 billion equipment is the largest and most powerful telescope to be sent into orbit. It's about 1.5 million kilometers away from Earth and is targeting distant galaxies, bright nebula, and a faraway giant gas planet. So the orbit location was chosen because it's the optimum temperature to view the universe in infrared, the wavelengths we feel as heat. And a look into the universe is a look back in time. The James Webb's mission is to view the stars and galaxies that first emerged after the Big Bang more than 13.5 billion years ago. It will also investigate the potential for life in other galaxies. Let's speak to Amitabha Ghosh, who's a space scientist who's worked on NASA's Mars missions. He's joining us from Mumbai. Welcome to the Al Jazeera News Hour. So we're just now getting the first full-color images, of course, to be released as a result of the James Webb Telescope. Right. Are they all that you expected them to be and more, or have they exceeded your expectations?
Well, they have exceeded my expectation, I would say. This is the first results from the James Webb Telescope. And let me just go back and tell you why this is so important. So human beings, although we are so technologically advanced, we are really very primitive in terms of space travel. So giving an example, the Voyager mission, which left Earth in 1976, is still radiating. It took us like maybe more than 40 years to get to the beyond the solar system. The lifetime from that Voyager mission to Earth is just 20 hours. So think that the universe is 13 billion light years big. And there is no way humans can, in their lifetime or with their machines, explore the universe. So the only way we have is to use a telescope. And that is what exactly this is. And the second question is, so the Earth has life, but the universe has 1 followed by 24 suns, like our sun. So it essentially has 1 trillion galaxies, and each galaxy has 1 trillion stars. So how unlikely is it that only one planet like Earth had life? So life is out there everywhere.
Right, and now we're hearing that the telescope has in fact captured a distinct signature of water on a distant planet. How significant is this? We don't know much about it yet.
Right, and this is going to happen over and over again as this telescope goes forward. You will find many such signatures in many such galaxies where human beings will never be able to visit. And so you will know that, so remember, this is a signature of water, not a signature of life. So all we are doing is we are looking at the atmosphere and picking up signatures of certain life-friendly materials. And so that will happen more and more, and you will see that there are many environments for life across the universe in these small, what we call exoplanets. So this will be all over, and there'll be many, many destinations where probably there is life.
So this is really a completely new way to explore the universe, from what you're saying. In a sense, it's a form of time travel. Tell us how we benefit from all of this, and how significant a milestone is it in the history of science?
So how do we benefit? It's a very good question. We are doing the news right now. We are very fixated on the now and the here. But actually the here is very, very small. As I said, the universe has 1 trillion galaxies, and each galaxy has 1 trillion stars. So we are really very, very insignificant, and we are insignificant in time. The human race has been around for maybe 1 million years. The universe is 13 billion years old. So it does show us how insignificant we are, and it kind of helps us find our bearings in time and space. I would say that is the biggest contribution.
Okay, tell us what we should be looking out for next when it comes to this James Webb Telescope, because from what I understand, the mission was originally expected to last for 10 years, but now NASA is saying that it has capacity to operate for 20 years.
Right. So another big question that we don't know. So one of the things is, if you look at one point on the universe, the further it is, the faster is that point moving away from us. The faster is the star moving away from us. This is called the Hubble's law. So if you extrapolate back in time, the universe was very, very compact, and that's what calls the Big Bang. So apparently 13 billion years ago, when there was this Big Bang. Now, at that Big Bang, there were a lot of stars which were very hot. And the James Webb telescope will help us see those stars. See, Hubble could not see those stars because in the visual wavelength, those stars were not visible. But the James Webb telescope has the infrared. So you will see the ancient universe, maybe 13 billion years, maybe 10 billion years ago, teeming with stars, stars that we have never seen. So, and this will help us understand many, many things. You know, there are very big mysteries, like, is there dark matter out there? The matter that we cannot see, but it encompasses the universe. So this is absolutely a mind-boggling frontier, and we will learn so much in the next 20 years.
Okay, so let me just ask you this then. I mean, it is a $10 billion mission. I think I know the answer to this, but you think it's worth the money?
Absolutely. Just put it in context of the GDP of the United States and the GDP of the world. And this is money spent this is spent on real scientists, and there are private companies who are developing it. So it creates real jobs on Earth. It's not like this money is completely wasted. So, and you know, it is these things like these, like the moon program that NASA had tremendous scientific output. And what we don't talk about is offshoots, technology offshoots. And the third thing is it builds capability in human resources. It builds computer scientists, different types of engineers. It really nourishes talent, because this is a very interesting thing to work on. So the intelligent people love it, and they then go to industry and do different things.
Okay, very interesting. Thank you so much for speaking to us from Mumbai. Amitabha Ghosh, thank you.
Thank you. It's always a pleasure.